Alright, so the name of this activity is painting the set. So it says Lynn needs to mix a specific shade of orange paint for the set of the school play. And the color uses 3 parts yellow for every 2 parts red. So this phrase right here, for every, should remind you of back in our ratios unit. Anytime you see the word for every, that's a sign that we're talking about ratios, which once again is a relationship between 2 numbers. So here, this is a 3:2 ratio. Complete the table to show different combinations of red and yellow paint that will make the shade of orange Lynn needs. So, looking at our table, we can see that 2:3 ratio in the very first row. So 2 cups of red for every 3 cups of yellow. And over here, it says total cups of paint. So if I took 2 of red and 3 of yellow, that would make a total of 5 cups of orange, right? So this total cups of paint that we're making is orange, right? That's what she's making. So now we need to fill out the rest of this table. We can use our ratio knowledge to do so. So remember, in order to keep a ratio equivalent, you need to multiply or divide every value by the same number. So if we look here, from 2 cups of red paint to 6 cups of red paint, I'm taking that 2 and I'm multiplying it by 3. So if I triple the amount of red paint I use, then I must also triple the amount of yellow I use. And by tripling both of them, that will also triple my total. So if I used 6 cups of red, then I would use 9 cups of yellow, and the 6 and 9 together would make 15 cups of orange. Alright? So now let's keep going. Here we can see that in this situation, Lynn made 20 total cups of paint. So the only value I have in this row is of her total. So I know in that initial ratio, she only made 5 cups, but now she's making 20 cups. So 20 cups is 4 times as much as 5. So that means if I quadrupled or multiplied this total by 4, then she must have also multiplied each of these values by 4 as well. 2 times 4 is 8, and 3 times 4 is 12. And then we can even check our work and see that if she used 8 cups of red and 12 cups of yellow, that would in fact make a total of 20. Okay? And so here we're going up to 18. You can see that 12 and 18 are not, 12 is not a factor of 18. 12 cannot multiply by anything to evenly fit into 18. But we could use this row right here. Because remember, all of these are equivalent. They would all make the same color orange. So we're going to use this second row because I know that 9 fits into 18. So I can see here that she took the recipe here and doubled it. So if she doubled the yellow to get 18, then she's also going to have to double this 6 to get 12. And then she'll also have to double this 15 to get 30. So all of these are just an example of a 2:3 ratio. Okay? So here, 14, 12 is not a factor, 8 is not a factor, 6 is not a factor, 2 is a factor. So how many times bigger than 2 is 14? I can see here that she must have taken that initial batch and she made it 7 times larger, because 2 times 7 is 14. So if she multiplied this by 7, she would also have to multiply this by 7 to keep it equivalent. And if you put those two things together, 14 and 21, she would get 35 total cups of red paint. Here is 16. So we could just take this initial ratio, or we could take this one. Either way, because both of these are factors of 16. So for the sake of it, let's just use this one. So if this one is obviously 2 times the size of this batch because she took the 8 cups here and doubled it. So if I doubled the 8, then I would also have to double the 12. Then I would also have to double the 20. You can see here too, 16 plus 24 is 40. Here, she got 50 total cups, so I'll use this ratio up here. So this ratio made 10 times as much as this initial one did, because to get from 5 to 50, I'd have to multiply times 10. So if I got 10 times the amount of total, then I also must have had to have used 10 times the amount of yellow and 10 times the amount of red. And here, 42, I can see that 21 and 42 were factors of each other. So if I doubled the amount of yellow from this one to this one, then I'd also double this amount. And I'd also have to double this, 70. So here is my total table. So once again, this is all an example of equivalent ratios. Meaning we multiply or divide each quantity by the same number. And we do that so it makes the same shade of orange, right? Because if we didn't multiply them all by the same number, let's say I multiplied the yellow by 3 but only multiplied the red by 2, then it would still probably make an orange, but the orange would be much more yellow than red. So if I want to make this specific shade of orange that is talked about in the instructions, you need to make sure that whatever you do to the yellow, you also do to the red. So, Lynn notices that the number of cups of red paint is always 2/5 of the total number of cups. She writes the equation R equals 2/5 T to describe the relationship. That's interesting. Let's see if that's true. So, she's saying that in order to find how much red paint you use, it would always be 2/5 of the total amount of paint. So let's say I wanted to find, let's say she made 5 cups of orange paint. So 5 cups total. So that means that if I made 5 cups, then I should have had to have used 2 cups of red. Let's see if that works. So when you multiply a fraction times a whole number, you just can turn the whole number into a fraction over 1 and multiply across. 2 times 5 is 10. 5 times 1 is 5. And that's 2. And that was correct. Yeah, absolutely. So when I had 5 total cups of paint, I did use 2 cups of red. So let's see if that works for another one. Let's do 50. So once again, the red paint should be 2/5 of the total of my recipe. Turn this over 1. Multiply across. 2 times 50 is 100. 5 times 1 is 5. And we get 20 equals R. And did I see that I used 20 cups of red for 50 total? I did. So she's right. This equation works. So what that means is whatever the total is, so here we can see the total is 5, and 2 out of the 5 cups were red. So that's why if you ever want to find a fraction of a number, you multiply times that fraction. So if 2 out of 5 of the total is red, then I just have to multiply any of the totals by 2 over 5, and I will find out how much red I needed. And now we're being introduced to these terms, independent variable and dependent variable. So, the independent variable is the number that multiplies, and the dependent variable is the answer you get. So, in this case, the independent variable, what gets multiplied is t. Total is the independent variable, and r is what we're getting, and that's the dependent variable, and r stands for red. So, let's think about what these words mean really quick. Independent and dependent. I'm sure you guys have heard the word independent before. So independent means that it can stand on its own, or it doesn't need anyone or anything to exist or take care of itself. So if you said that, you know, I'm an independent person, that means you don't need any help from your parents or friends. You know, you just take care of everything yourself. And the reason why we call this variable independent is because this number, you just put it in, right? So like when I was plugging in these numbers, I was just choosing the independent variable. I'm like, okay, so let's put 5 in for t, and let's put 50 in for t. And then dependent is the opposite of independent. It means you do need something, or something else changes you. So the reason why it's the answer you get is because depending on what I multiply, that will give me a specific answer. So here, when I plugged in 5, I got 2 for r. When I plugged in 50 for t, I got 20 for r. So what I got for r depended on what I plugged in for t. So that's why the answer you get, the number that's on its own, is always the dependent variable, because it changes based on what you plug in for the independent variable. So now it says write an equation that describes the relationship between r and y, where y is the independent variable. So up here it says independent variable is the number that multiplies. So y is going to be multiplied by something. R is going to be the dependent variable again. Okay. And so I can see that when I compare red to yellow, it's a 2-to-3 ratio. So R is always going to be 2/3 of y. Will be my equation here. And now for number 4, it says write an equation that describes the relationship between y and r, where r is the independent variable. So that means y is the dependent. Always remember, independence is the one that does the multiplying. And so, once again, it's the same ratio, but backwards. So to find y, this is a 2-to-3 ratio, so y will always be 3/2 of r. So real quick, just to check our work, so let's say I wanted to find out how much yellow I have to use when I use 6 cups of red paint. Then I'm going to plug in 6 for red. And I would get 18/2, meaning I would get 9 for yellow. And is that true? If I used 6 cups of red paint, would I have to use 9 cups of yellow? And looking back up at my table, that is true. Okay, so these are variable equations that I can use instead of ratios to solve all of these problems. So it's important to note that y is always bigger than red, or sorry, yellow is always more than red. So that's why y is 3/2 of r, right? 3/2 is greater than 1, whereas r, which is always less than y, is a fraction of y. 2/3 is smaller than 1.